This is problem 5-29, and in it we have Gina who is selling a piece of land, and at closing she has two alternatives. She can either accept a lump sum from the buyer of $16,866, or the alternative is she can accept a mixed stream of payments that are included in the table down below here. So one of two choices, and what we're trying to figure out is, based on an assumed rate of 7%, which would provide Gina the highest future value at the end of 5 years. Now, 5 years is her time horizon where she plans to buy a house. And so whichever option she chooses, she's just going to let it sit into an account and accrue interest at 7% and not pull it out until the end of 5 years when she's ready. So the first step was to figure out what the future value of the lump sum option is. So that I already did in Excel. By now, probably a pretty easy calculation for you. So it's just future value in the formula builder at a rate of 7% over the course of 5 years. And the lump sum payment is $16,866. Entered it as a negative number just to kind of consider it as a cash outflow, so that our resulting answer would show as a positive number, which would be the money that we would take out of the account to put down on the house. So that's the easy part of the question. The next part of the question is to solve for the future value of the mixed stream of payments that are in the table. So if you saw the solution video for the financial calculator that I did, you'll note that it's really done in two different parts, and that's because there isn't a net future value option to solve the problem in one step. So on the calculator, we basically just found the net present. We used the net present value or the cash flow register to find the net present value of this stream of cash flows, and then we just converted that present value of all these flows into a future value at the end of 5 years. So we really did it in two steps, and we did it that way in order to save us the alternative, which is to solve each of these individual cash flows for a future value. So considering each of these cash flows as a present value, solving it for a future value at the end of 5 years, and then adding up the individual results to get our grand total for the stream. So we could do, to kind of keep it consistent with the calculator solution, we could do the same thing in Excel, meaning that we would utilize the NPV function, and using our rate of 0.07, we would enter the values of 6,000, then we got 5,000 as the year 2, add a few more value boxes here. Year 3 is 3,000, 4 is 2,000, and finally year 5 is 4,000. So these would be the mixed stream payments from the buyer to Gina. And if I click done, that gives us our present value of $16,801.30. So that's not our answer yet. So that is what the present value of these payments would be to Gina right now. That's what it's worth to her right now. But we're actually wanting to calculate, or she's wanting to know what the future value is of these payments, assuming that they sit into an account for 5 years. So what we need to do is convert this present value that we calculated into a future value. So we have taken this mixed stream of cash flows and converted this into a lump sum present value that we will now calculate out a future value at the end of 5 years with. So to do that, we will just use the future value function, and our rate again is the 0.07. Our present value, and I'm just going to reference it in the sheet here. So it's cell A4. That's our present value, and I'll put that in as a negative just so that the solution is positive. And here now is where we need to make an adjustment, and that's concerning the number of periods. And this is the same thing that I explained with the financial calculator solution, in that we are working with a 5-year period. However, the difference is that the payments on the mixed stream were made at the beginning or will be made at the beginning of the year. So we did not account for that when we calculated the present value of this mixed stream of cash flows. We calculated it using the 5 years as we needed to for that function, but what we have is really we would be shorting ourselves a year's worth of interest growth because these cash flows are made at the beginning, or these payments are made at the beginning of the year and not the end of the year. So if this had said, or the problem had said that these payments would be made at the end of each year, then we would use 5 as the number of periods like I'm sure you're used to. But since the payments are made at the beginning of the year, a shortcut is just to simply add a year to it, and we'll make it 6. So the number of periods is 6 in this case, again to account for the fact that there's 1 extra year of interest growth on the cash flows, being that they're paid at the beginning of the year. So with that, click done. And now we have our future value of these stream of cash flows, and that is $25,214 and 22 cents. Okay. And then finally, it's just asking us which alternative would we choose, and just economically speaking or theoretically speaking, we want to choose the alternative that gives us the highest future value. In this case, it's going to be the mixed stream of payments. And for a little bit more advanced Excel users, we could always copy the information over to a spreadsheet and play with the numbers in order to solve it for future value in a little bit different way. And we could copy it over via the icon here, or if it's a small amount of data, I prefer really just to type it in myself, so I'm not having to open up and deal with multiple spreadsheets. So just as an example, if we have our cash flows, we can just type in real quick. And our interest rate in the problem is 7%. So 0.07. And so this is our rate. These are our cash flows. And then these will be the periods. And we'll need to enter these in the reverse order, because if we're going to calculate future values for each of these cash flows, we need to calculate them over the correct periods of time. So 6,000 is the first payment, and it's going to receive interest or accrue interest for 5 years. 5,000 is the second payment. It's going to accrue interest for 4 years. 3,000 for 3 years, and so on. So what we're doing is just we could do one future value problem, and then just copy the formula for the other years. So this just makes it so we only have to do one problem in the formula builder instead of 2, as we did previously. So I'll just reference the rate here in the sheet, and then the same thing, reference the number of periods, and then I will reference the present value, which is the first cash flow. Let's make that a negative number so our solution is positive. And then when it comes to the rate, when we finish the formula here, and we want to copy the formula down to the other cells, so they're not having to do the same thing for each of the other cash flows. When we copy the formula down, if we don't use an absolute reference for the rate, then the rate's going to copy down these empty cells below it. So the way we get around that is we just use an absolute reference on the rate in the first formula, which is done with the dollar signs. And it really just locks in this cell D12 as the rate for each formula as we copy it down in column C. So I'm just going to click done there again, and we'll just copy the formula down to the other rows. And what we've done is we've just performed the future value calculation for each of these cash flows, which is, as you recall, the kind of the long way for you to do this by hand instead of using the previous method or through the cash flow register of the calculator. This is just a way to manipulate Excel to do more of the work for us by just copying the formula down to the other cash flows. And we can just sum them up here. So we'll just equal sum and select all the applicable figures with the mouse. And then as you see, we get the same answer as we had before.